There's a clock counting down to the day humanity gets locked on Earth forever. In May of 2026, it was calculated at just 2.5 days, and nobody's talking about it. Not a meteor, not aliens, us. Scientists gave it a name, the crash clock, and in May of 2026, its calculated warning window had fallen to just 2.5 days. That's it. That's how long we'd have. From the moment we lose the ability to steer satellites out of each other's way, to a chain reaction collision that could seal off space for good. Now, stick with me for 10 minutes, because this is one of the most quietly terrifying statistics in science. Okay, so what is this thing actually? Researchers at Princeton, the University of British Columbia, and the University of Regina built what they called CRASH, collision, realization, and significant harm. The question it answers: if every satellite operator suddenly lost the ability to dodge due to a solar storm, a software failure, a cyber attack, whatever, how long until the first crash happens? In 2018, before megaconstellations existed, the answer was about 121 days, only 4 months of breathing room. By the May 2026 calculation, though, that warning window had collapsed to just 2.5 days. That's not a slow decline, that's a cliff. And this metric doesn't even count what happens after the first collision, which would just be how fast we'd get there. The real story starts after. Think of it like a smoke detector, not a fire. It's not telling you the building's already burning, it's telling you how little time you'd have to react if it started. And that reaction window has shrunk by roughly 98% in under a decade. So here's why the clock is collapsing. One company is reshaping orbit faster than anyone predicted: SpaceX's Starlink. In the last year alone, Starlink satellites performed 355,000 collision avoidance maneuvers. You heard that right, 355,000 dodges. That's 3 times what they did the year before. Every single satellite up there is now swerving out of the way roughly once a week. And it's accelerating. Some estimates put Starlink at close to 1 million maneuvers a year by 2027, if this keeps up. We've gone from space is big, don't worry about it, to satellites playing bumper cars on autopilot thousands of times a day. By the way, if you're not subscribed yet, now's a good time, so you do not miss any new content. So what happens when that clock hits 0 and nobody's there to swerve? This is where it gets genuinely nightmarish. It's called Kessler Syndrome, a theory from 1978 that said pack enough objects into orbit and one collision creates debris. That debris hits something else. That creates more debris, which hits more things. It's not a chain reaction that fizzles out. It's a chain reaction that feeds itself and keeps going. Here's the part that should worry you. Scientists say we've already crossed the density threshold that theory warned about. Some altitude bands above 600 kilometers are already past the point where a runaway cascade is a live possibility. Not science fiction, a live possibility. This decade. One bad solar storm, one software glitch, one collision nobody saw coming, and that's the trigger. And before you think this is some far-off hypothetical, it's already happened. Twice. In 2009, an active satellite called Iridium-33 collided head-on with a dead Russian satellite, Cosmos 2251, at over 26,000 miles an hour. That single crash created more than 2,000 tracked pieces of debris, still up there today. Then, in 2021, Russia deliberately blew up one of its own dead satellites in an anti-satellite weapons test. The strike created over 1,500 more trackable fragments, and it happened close enough to the International Space Station that the astronauts on board had to scramble into their capsules and shelter in place, in case debris hit the station. NASA says that debris cloud will keep threatening spacecraft for years, and maybe for decades. These weren't simulations. This is the test run for exactly the kind of event the crash clock is measuring. Now, let's make this real. If Kessler Syndrome fully triggers, low Earth orbit doesn't just get messy, it becomes a shotgun blast of debris moving at 17,000 miles an hour. At that speed, a paint fleck can punch through a spacecraft. So here's what's actually on the line. GPS, gone, or badly degraded. That means your phone's map, your bank's timestamps, airplanes, shipping, and the power grid's timing systems. Weather satellites, gone. That means hurricane tracking, storm warnings, and agriculture forecasting, all blind. Satellite internet, gone. Starlink, the very thing driving this risk, would likely be one of the first casualties of the mess it helped create. And it's not just Earth that gets cut off. Astronauts on the space station would face more shelter-in-place scrambles like 2021. Cargo and crew launches could get delayed for weeks, waiting for debris fields to clear. And the ultra-precise timestamps that synchronize global financial trades down to the microsecond would degrade too. Emergency response teams that rely on satellite links to coordinate during hurricanes and wildfires would be flying blind at the worst possible moment. Insurance markets that price disaster risk using satellite data would lose their most reliable input overnight. And the scary part? Once certain orbital bands go, they don't come back next year. Some models say those altitudes could stay unusable for decades. Some say centuries. Because debris up there doesn't just disappear. It can take that long to naturally fall and burn up. Okay, so is anyone actually doing something about this? Yes, barely. Europe's ESA has a mission called Clear Space 1, launching this year, built to grab dead debris out of orbit with a robotic claw. Japan's got ADRAS-J2, going after leftover rocket bodies. There's a new push for a zero-debris rule. Satellites would need to deorbit within 5 years of retirement instead of the current 25. But here's the problem. There are over 16,000 active satellites in orbit right now, and nearly 10,000 of them belong to just one company. Each cleanup mission targets exactly one piece of junk, one at a time, while we're adding thousands of new satellites a year. It's like bailing out a boat with a teaspoon while someone's drilling new holes in the hull. If this topic matters to you, and it should, smash that like button right now, so this reaches more people. Because the more of us who understand this, the more pressure there is to actually fix it before the clock runs out. Now, here's the part that should really bother you. There's no real referee up there. Space law was basically written in the 1960s, back when maybe a dozen countries could even reach orbit. There's no binding international treaty that forces any company or country to clean up its debris. No global agency with the authority to say, no more launches until you fix this. The United States has a bill sitting in Congress right now, the Orbits Act, meant to jumpstart a real debris removal industry. But it's been stuck for years. Meanwhile, every country and every company gets to make its own rules, or ignore them, while the orbit above all of us keeps getting more crowded. It's the high seas before maritime law, except if this cascade happens, there's no salvage crew coming. Most doomsday countdowns are exaggerated. This one isn't hype. It's a peer-reviewed metric, published by actual orbital scientists, and it's been dropping for years, not spiking for a headline. We didn't lock ourselves out of space with a bomb or a war. We're doing it by accident, one satellite launch at a time, because it's profitable and nobody's required to clean up after themselves. And here's the thing. Humanity has actually solved a problem like this before. In the 1980s, scientists found a hole in the ozone layer. Industries were told their chemicals were the cause, and instead of shrugging it off, nearly every country on Earth signed the Montreal Protocol within 2 years. The ozone layer is recovering today because of it. Orbital debris is a smaller, more solvable problem than that one was. The technology already exists. What's missing isn't ability, it's urgency. 2.5 days. That was the warning window in the May 2026 calculation if the dodging ever stopped. Just a few years earlier, it had been 4 months. This isn't a problem for someday. It's a problem for this decade, maybe this year. This clock isn't going to fix itself, and honestly, most people have never even heard of it, which is exactly why I made this video. If you want to actually understand the stuff quietly reshaping our future before it's mainstream news, this channel is where you get it first. Subscribe, hit the bell, and drop a comment. Should we be regulating this before it's too late? Or is it already too late? Discuss it in the comments section. I read every single one. And if this blew your mind, there's another video linked right here that you need to watch next. Because this isn't even the only clock ticking. 2.5 days. Set your watch.